Hello, I am Andreas Zeller. I'm the author of the Debugging book, and I'm here to present you a new chapter. Okay, I just switched on the recording, so here we go, and we do have our participants still. And of course, we are again recording this entire session for your pleasure. So let me start the recording here too, just in case. So now, two recording streams happening at the same time. Let's see how this works. Okay, so ladies and gentlemen, we'd like to start today with a discussion of the project that is going on right now. So we have sent out the description for the second project on Friday, and I understand that some of you still have questions about the new project. I hope you all have seen it, of course. So now's a good time to discuss questions. You can either pose them in the question and answer session, so in the question and answer window of Zoom, or we can also go first through any open questions from the forum. Konstantin, what are the things that you consider most interesting?
Yeah, let me start. Actually, there is just one question.
One question.
Though it's interesting, and it is about may have feature, the may have part of the project. So let me just read it. Are the students free with the implementation of a faster reducer? Because it is stated that one should implement an AST delta debugger, but in principle, one can do something even better and propose some custom approach, which is even faster.
That's a good question. You may be able to come up with a combination of structured debugging, that is syntactical debugging, as well as that is working on the AST, but also working at the lexical level when you can try to remove individual spaces and whatnot, which are irrelevant from a syntactic point of view, but still reduce the size of the program a lot. I would stick for the project, I would stick with syntactical reductions, because lexical reductions tend to be slow and a bit gimmicky, because in the end, well, you can remove individual characters, but it suffices that entire structures be removed. However, if you have interesting ideas on that, come and see me with some of your ideas. Maybe we can make a scientific paper out of that. Further questions from the forums or from our audience?
So no questions regarding this second project.
Okay.
I expect that we will have more questions later on, as we do have now with for the first project. So let's take a question from the Q&A.
Yes.
So I can read it for you. So the question is, we implemented a mix of mayhaves for both parts. So
this
we
is
are
wondering for the first project, right? Okay, good.
Yes, I guess so. So we are wondering whether every mayhave of part one must have a GUI implementation, or it is enough to have a console at the GUI where you can use the commands like bp until or bp after. Because when implementing all may have functionality, the GUI overloaded. Yeah, actually it's true. And if you use button for any feature, the GUI may be really overloaded.
Yes, indeed. If you have a GUI, you have to, well, that's if you come up with a graphical user interface that gives you one single command for every single function, you're going to end up with a horrible user interface. So for the graphical GUI, I think this is even stated somewhere in the project description. Come up with, so the command line debugger, which is also part of the project, should of course implement all the commands, but the GUI should implement the most important commands. And this choice of most important commands is actually left to you. but do not try to implement every single command of the command line debugger in the graphical user interface. That's not going to work that well. But, well, and as you suggest, if you want to have a console where you can enter commands, that could be cool. Or that could be cool. It could be cool, but also remember that you will need an interpreter to interpret all these commands. If you go for the pure JavaScript solution, then you will have to re-implement your command line processing in JavaScript again, which is not that fun. So I'm much happier if you have your GUI focus on the most essential parts, and then as in real life, users can then choose whether they want to have something that is good for novices, a graphical user interface, or whether they want to work with something that gives them the full power of the command language, which is a command line interface.
Good. So it looks like we don't have any other questions. We have some questions on the forum, but I think most of them are already answered. If not, I will answer them the next hour.
Yes, we're always working hard on answering all questions as quickly as possible, such that it can work. The only problem is, of course, that if you folks start working on these projects, say 3 days before the deadline, then there will be nothing on the forums for weeks. And in the last 24 hours, everything is going to explode, and we'll be typing as fast as we can to answer all of your questions. Classic could be, it's 1 hour before the deadline. How do I install Python? Please give instructions. Oh, yeah, sure, we can do that. I hope our deadline is not somewhere on Konstantin. Our deadline is not it's not at midnight or something, right?
Well, it is.
It is really. Oh, okay, good. So you will be there for the last hour. Let's see how things will work.
I wouldn't say it's a great present.
Yeah, next deadline is going to be at 6 p.m. or something, such that we can all enjoy the weekend. Well, whatever's left of it now with Corona lockdown. Okay, good. I wouldn't mind leaving you some time to go out shopping for your last Christmas presents while you can. Of course, you can also be perfectly reasonable and stay at home and work or do whatever, anything but spreading viruses. So I think we can go directly into the next chapter. Konstantin, what do you say?
Well, I think it's a great idea. By the
I
way,
think it's a great idea. Okay, good.
It looks like Johannes wants to join us.
Johannes is back. Oh, Johannes wasn't here moments ago. He came a bit late, so let me have him join here too. And we can, hello, Johannes. You are now a panelist. Johannes.
Hi.
Great to see you. Any questions from students you'd like to get mentioned or discussed?
Not at this point, I think.
Not at this point. Okay, great.
Well, maybe yet another announcement.
Yes, the timeline.
Well, it's not an announcement. Well, maybe you have another one. So I just want to mention that it's not possible to unregister from the course right now because the deadline for HISPOS is passed already. And even if we unregister a student from the course, from our system, it doesn't mean that in HISPOS, the course will be canceled. So it's no longer possible.
Which has the practical implication of you being able to repeat this very course only once more in 1.5 years, whenever it will be offered again. Other than that, do failed courses have any implications? I think they can show up on some of your. They may show up on some kind of certificate, right?
There is one kind of certificate where they show up, but it's not the transcript of records. So
thank you.
Yeah,
I always wanted a transcript of things which I tried and where I failed. Actually, even during my own studies, there were quite a couple of courses which I took for the first 3 weeks or so, and then I decided it's bogus, and then I never went again. But actually, technically speaking, these would all have shown up as failed on some transcript of records, if only we had had them at this time. Yep, not all courses are that great. I understand that. Some are, however. Well, let's try to, and if they aren't, let's try to make debugging great again, and then we can start with stuff. Okay, no further questions. Konstantin, Johannes, question answer forum. Then we'll go right away into our next chapter, which is the last chapter of 2020, last assignment, because today is the last lecture of 2020, at least as it comes to automated debugging. Now is a perfect time to actually send an applause or something. Unfortunately, we don't have that. Okay, good. I need a button where I can send myself an applause or something. Just press that button and people will be crazy. Okay, good. I'm digressing. We're close to Christmas. So let me go right into things here. And let me share my screen. Where are we? No, that's not me. Let me share my screen for Zoom while I'm recording things as well. So, and here we are. So, how cool is that? You should be able to see my screen now, right?
Yep.
Okay. Size is okay, or should I make this bigger? I can make this bigger.
Yeah, it's okay.
It's okay?
Yeah.
Okay. The only problem is that it doesn't move anything. Oh, here we go. It's a bit slow. I think I'm overloading my machine at this point. Yes, it really is slow. Let's wait a second until things stabilize here. So here we are. And I'm switching this off. And we are waiting. I just stumbled across a page today telling that Chrome is an absolute memory hog. And we should all uninstall Chrome. Simply installing Chrome already, not even using it, may already slow down your computer tremendously. Certainly, it's not me running Zoom and recording and video filters all at the same time on a machine that is simply too weak for that. Okay, we can make this very short today because the concept is really simple, in particular, since you already have seen our last chapter on reducing inputs. This chapter is very similar in that it is also about reducing. However, we are not talking about reducing an input to a minimum. Instead, we are working on reducing a set of changes to a minimum. So if you have ever worked with others on a project, if you're a student, this may not necessarily be the case, but I can tell you it will certainly be the case once you work in industry, because there are very few projects that you run by yourself. You will be confronted with the fact that all of a sudden your program that still worked yesterday no longer works today. And this is because of some change happening. And this can be a change of yours, but it can also be a change that was made by others and that you just imported. So, and today we are applying delta debugging on these changes in order to figure out which change it was that actually causes your program to fail. There's actually two ways in which you can isolate such changes. And the first way is related to the usage of a version control system. Seriously, if you do not use a version control system for your software, don't even bother going into any kind of automated debugging or even debugging. Fix your version control first for personal use as well as for project use. If you don't use a version control, you have literally lost all control over your over your project and over your coding. And the situation we're in here is we're having a program that comes in 8 versions, V1 up to V8, and version 1 is the one that passes, and version 8 is the one that fails. And you want to know when exactly the program failed, or at which point in time the program started to fail. You could now go through history v1, v2, v3, v4 linearly, but this is something that is not very efficient, in particular if it's not, as it is in real world project, if it's not just 8 changes that have been made, but rather say 1,000 changes. If you work at a big company like Google or Facebook, you're having dozens of changes, sometimes per second, to a big piece of software. So we're actually talking about thousands of changes that are being made at the same time to various parts of the infrastructure. Thinking about it, it's actually a miracle that all this stuff works. And so a much better idea here is to proceed by so-called bisecting. That is, and that's very simple. You choose a version that is right in the middle of this history, such as here v4 or v5. You try out this one, and if it passes, then you go for the interval between the one that passes and the one that fails. You keep on doing this until you narrow down. This is a logarithmic progression until you narrow down the single change that causes the program to fail. If you are using the Git version management system, you are very lucky here because Git actually allows you to do this bisecting automatically. There is a command in Git that allows you, that actually guides you through this process. This is super neat. Here we have our 8 versions of our remove HTML markup program. The versions are identified with these hashes, which is, well, which is unique, definitely. So there's no way to mistake anything. They're not super convenient to work with, but you can also work with prefixes if needed. And you can now check out individual versions in here and find out that the first version worked and the last version does not work. So this bisecting thing in Git is something that is very simple. You go and do git bisect start at the very beginning. And when you do git bisect start, then you have to say, you have to state which is the good version. You enter in the command line git bisect good. You say my first version is the good one and the last version is the bad one. And then git bisect immediately tells you what to check out. And it automatically checks out for you the version in the middle, the 4th version, which you would now go. And so this is the version to check, which you can now build and test and see whether it passes or whether it fails. And you can now say, so we're testing this thing, we're just saying git bisect bad in here. And now the situation is v4 failed. And since v1 passed and v4 failed, we are now going to check out v3. That's also something that Git automatically does. Git bisect automatically gives you the 3rd version. So you can list this out, you can try this out, and then you find out that this version fails. So Git bisect automatically gives you version 2. And with version 2, you can test again. And at this point, you already have found the moment in time when the program failed, because v2 turns out to be failing just as well. And since v1 passed and v2 failed, now you can go for looking at the change. And this is actually something that Git bisect in the very last step actually tells you automatically. It even tells you who was the author of this particular change, such that now you can now so you can now run out of your office, knock on the door of the one culprit who is around there and tell him or her, oh boy, what have you done there? This is just horrible. Well, that's not the way it works. What you do instead is, what you do instead is you look at what actually was the change that was being made, which you can do using git diff. It's all built in into, this is all built in into version control. And this is where you can now check which change it was that actually introduced the change. And here we have it. Here we have one line. This is this line which we're seeing all over again, because this is the one culprit line, which among others was introduced in this very version. And since it was introduced in this very version, well, at this moment, the error was there and the program failed. So this is already pretty cute, because Well, assume, because if you have a means to check out whether an error is there or not, you can very quickly process in a guided fashion with Git Bisect, and this will get you towards the change that causes the program to fail. You can even do better, and that's even cooler, because what you also can do is you can write a short script that actually tests your software, that tests whether the failure is there or not, which we do over here. So this is the script that we're having. We're having a small Python script that simply imports our function and checks whether the error is there or not. And you have 3 different return codes. If the script returns 0, then this means that the error is not there. If the script returns 1, then it fails. And if there is some other error, which is not the error you're looking for, then your script is supposed to return the special value 125. No idea why it's 125. I guess this was simply a value which is not used very often. And with this script, you can entirely automate the entire Git Bisect process. Because if you have this script, again, you do Git Bisect start, you say what the good version is, you say what the bad version is, and then you do this special thing, Git Bisect run, where you actually state the script that is supposed to be executed, which we have here. And if you do this, all of the Git Bisect stuff is going to happen automatically. Git is going to check out automatically the version, is going to run your script, is going to check out next version, is going to run your script, and it immediately gives you the version that actually fails. And you can look up at the difference that causes the error directly onto your screen. This is amazing. This is probably one of the best debugging tools as it comes to changes ever, because it's so easy to use. And in particular with the scripting form, you just press a button, relax, and let the test script do its glory. In Python, it suffices for us that we simply import the function in question and we do the test. If you do this in other languages, then of course it doesn't simply suffice to check out the source code. You also have to build things. So you probably have to set up appropriate build commands in your script or do them manually. And since building can take quite a long time, in particular looking at older or newer versions, this is where such a script can be very handy, because you just do Git Bisect run, press a button, and everything happens automatically. There you go. Go and have a coffee, and 5 minutes later, when all the individual things are being done, then when all the things are being done, that's when you can then look at the failure inducing change. Here you go. Now, this is still a somewhat simplistic situation, because this assumes that the changes that are being made are so small that you can quickly find out what's going on. So here, actually, all of our changes fit on one screen. In practice, however, you will frequently end up with changes that include dozens or even hundreds of changed lines, or even worse, when people come in and merge patches, big sets of patches that have accumulated in some other branch, and they merge them back. Sometimes this can even be hundreds or thousands of lines that all of a sudden have changed. And there you are, and you know that adding these 1,000 lines to your code causes the failure. Well, there you are. Oh, good. It's good that we now know that it is these 1,000 lines. What do we do next? There's a way to actually narrow this down even further. And the idea is that you can actually break down these changes further into so-called patches. And every single patch, it just changes one single block of lines in your program. And when you have this set of patches, such as over here we are introducing quote equals false, over here we are changing this condition, over here we are changing this condition, over here we are introducing these 2 lines. These are 4 separate patches, and each of these patches can be applied separately. And the question is there a set in there which actually, is there a minimal set in there which actually causes the failure to occur? And this is what we do in the second half of this chapter, we are introducing some mechanisms to actually compute those differences and getting a set of patches back. So here we go and compute the difference using this diff function between two versions, and we get a set of 4 patches, each of these changing one particular location in the source code. And we can actually look at what these patches are doing. Here's the first patch. It introduces this line quote equals false. The second patch changes this condition to have an end not quote. So there's the third patch. And the fourth patch then introduces this C equals quote or C equals quote and tag, which is, as we already know, the failure inducing line. And we have a function called patch, which actually allows us to apply an arbitrary subset of these patches. If we apply all patches to our original version, we get the new version, but we can also go and apply just a small set of patches. For instance, if we just apply this single patch up here, quote equals false, then we get this line quote equals false, where none of the other changes so far. So now we have patches as first-class objects. We can apply them, and when we have applied them, we can test them. And so we have a set of patches, and in this set of patches, we can find out which one is the failure-inducing patch. And this is something where we can then again go and apply delta debugging. Actually, delta debugging was first introduced on patches. This is also where the name delta debugging comes from, because we're talking about deltas between individual versions of code, a difference between 2 versions of code. Only later was it found out, well, only later did I find out that this actually can generalize to arbitrary parts, and now it's actually, I guess, much more frequently used on input than it would be on code changes. And now what we do is we can invoke a delta debugger on the set of patches, and then we quickly find out that only 2 patches are required to actually cause the failure. Namely, what we have here is our failure-inducing line. This is what causes the failure, and since this refers to the quote variable, we also need to introduce this quote variable in the first place. The conditions that are listed in the other 2 patches actually are not relevant for the failure to occur. Then we go even further, because delta debugging not only allows us to minimize a set, it can also minimize a difference between 2 sets. So you have a passing set, which is empty, a failing set that is full. And the question is, can we have a minimal difference between a passing set and a failing set, with this minimal difference actually causing the failure to occur? And this is indeed what we're doing in here. And then what we get as a difference is precisely the one single line in here, because our first patch, quote equals false, does not change whether the failure is there or not. The program is still passing. But after we introduce these 2 lines, the last patch, this is when we get the error. And this is now what we can identify as a cause of the error. Because things are so nice, we're introducing a class called change debugger, in which you can then state which is the first version and which is the last version, and it will automatically compute the differences between the 2, and it will automatically compute the minimal difference in here. So you just write with change debugger, and you give the 2 versions, and then you invoke your failing, then you have a test function, which again raises an exception when it fails. So there you go. And then this change debugger has a method called minimal patches, and it will automatically produce a minimal difference between these 2 versions. So this is something that is very easy to use, again, like delta debugger 2. All you need is 2 versions in here and a test, and it will automatically narrow down all these individual parts. That's already all there is. And what we can learn from that is, if your program fails and you do have an older version that works, this is gold, because then rather than figuring out in these whatever 10,000, 100,000 lines of code that now fail, you can now go for the difference between the version that worked and the old version that worked, the new version that failed, and you can narrow down this difference even automatically, pinpointing those lines that cause the failure. So the question is, can we simply remove those lines that cause the failure? Well, it's technically speaking, yes, but you may also lose some functionality along the way with that. So this yields important hints on where the failure is, but it does not necessarily give you an immediate way to fix the error. Of course, well, removing these things also removes the failure, but the problem is, of course, that this may also remove other functionalities. So you still have to do some homework in order to figure out how best to fix the program. But as a starting point for finding out what is it that went wrong in here, such bisecting or even such delta debugging on changes can give very, very important hints on when exactly a program failed and why it failed. And that's already all I'm having from my side at this point. This was very quick. Simple idea, delta debugging on changes. And I am happy to take questions. And I hope, again, you will be enjoying reading this chapter. And I hope you will be having fun trying out some examples some examples yourself. Feel free to apply this on your own code and let me know whether this works. Thank you very much. And I'm open for questions. So, Konstantin, Johannes, what do we have in our Q&A session? Anything?
No questions yet.
No questions yet. Oh, I am a genius. Everything I'm writing down here automatically is so perfect that there is no question ever. Or it's just so confusing from the very beginning that nobody finds a way to actually ask questions. Okay, good. Konstantin, Johannes, do you have any questions? Actually, I think we should stage these, such as I should send you a piece of paper with a couple of questions to ask, such as, Professor Zeller, this is all genius. Where do you get all these ideas, or something like that?
Sure.
Okay, the answer is under the shower. Now for a real question.
Have you already talked about the timeline?
Thailand.
No, the timeline
regarding the project. Oh, I thought you wanted to. I thought you wanted to ask some technical questions on when does this work? I have tried out Git Bisect and it's not nearly as good as you said, or something like that. Now we'll keep the timeline for a second.
Right.
Johannes, have you ever used Git Bisect? Did you know about it?
I did know about it, but I haven't used it yet.
That might have been a mistake. Konstantin, Git Bisect, did you ever do that?
The same. I do know about it, but I had no chance to use it.
Yeah. These are really great tools, folks.
How often do you use it?
Git Bisect.
Yeah.
I never use it because my programs once they work, they never fail again. So,
nice.
No, I'm just joking. Actually, I knew that Git Bisect existed, but I specifically researched Git Bisect for this very chapter, and I was absolutely amazed that it not only works in this automatic way, but also in this manual way. And I think I'm going to use it very, very often from now on. Whenever, in particular, when I'm writing some code with others, or when I'm writing some paper with others, I want to know when things went wrong, and Git Bisect will be perfect for that. It's always a question of setting up a test case. That's the one thing that really made it is the extra effort. And this is why I'm building these small tools, such as with Delta Debugger do something, such that you can very quickly get to results without having to set up a big test framework, test harness whatsoever.
Okay, I have another question. Since you did get know a lot about Git Bisect, what would you change or add to this functionality?
I would, of course, change it to integrate delta debugging such that it would really narrow down the changes, but perfectly happy with it. But the problem is really if you do Git, the problem is really what does your commit history look like? If you have a developer who commits after every single small change, okay? I just introduced this, commit. I just introduced that, commit. Or I'm having this big feature, I'm introducing a branch for that. And then I'm adding feature by feature until it's complete, and then I'm merging back the branch. If you have such small, very small changes with Git commit, then it's great because then Git Bisect can also operate on these small changes. But if you have a developer who says, okay, I'm going to work for a day, a week, and then I'm done, I'm going to do a commit and then a Git push of my one single complete version with thousands and thousands of changes, then Git Bisect is not going to help you very much, because Git Bisect will not be able to narrow this huge change down to something that is smaller. And and you will actually be amazed at how many at the average number of files that are being touched by a single change in real industrial projects. Talked to a telecom manager once, and he told me that the average number of files touched by a change is 7. Average, I'm saying, not the maximum, the average. So on average, any single feature, any single fix, anything that needs to be changed, any single commit touches 7 files. Can you imagine that? And then, and this is the sheer size of things. This is how things are connected. We're talking about systems that consist of hundreds, thousands of lines, maybe millions of code lines, and every single change affects at least seven different files, not even 7 different locations, 7 different files, and keeping track of that and figuring out what is actually going on is such a huge problem. And this is where things like Git Bisect, possibly even combined with delta debugging, can really be a boon, because they allow you to really, really narrow down what's going on. On the other hand, probably rewriting this system such that a single change, well, affects, say, 1, 2 locations in 1 or 2 files, possibly better 1 file or something like that, would probably be better, because 7 files on average for a change is way too much. This does not bode well for the long-term maintenance of such code. But this manager actually was proud, because he had brought it down from, I don't know, 9 or 10 files to only 7 files, and she was very proud of that, because this was better than the average in industry. Well, okay. This is why I'm so super happy to be in academia, because I can do these things on these little toy programs with 12 lines, with 14 lines, with 16 lines, whatsoever. And everything is beautiful, everything is elegant, everything fits on one page. That's all great. But reality with real world code is whoop, totally different scale. Get used to that. Good. That was a long answer to, I'm not even sure whether this was an answer to a question. Okay, Konstantin, Johannes, any more questions? Otherwise, we'll talk about the, oh no, we have a question here. Does the number 7 correlate with the dependencies? Yes, it does, because dependencies simply mean that things have to be changed together. If A depends on B, then every time that B changes, A has to change. And then if A and B, so if you change B, A has to be changed as well, and this then of course propagates through your module dependency graph whatsoever. And yes, it's a hard problem. So Konstantin, Johannes, any more questions?
No.
Okay, then let's call it a year. No. Let's talk about timeline. Timeline. Johannes, what is the big question about timeline?
Basically, the question is that students wanted to know when they could expect deadlines for the remaining projects.
Indeed. And we have talked about that.
Yep.
And the answer is?
Okay, so I just wanted to know whether you want to make the announcement. That's all. Okay, so the answer is for the next project, the second project, the deadline is, let me see, January 15th.
Okay.
Then we will immediately start with the third project, for which the deadline will be February 5th. So basically the last day of lectures. And the fourth project will have an extended deadline because we are aware that there are exams during that period of time. And the deadline for the second project is therefore mid-March. Exact deadline. We haven't decided on an exact deadline, but it's mid-March, somewhere mid-March, I would say.
And the last project will then be something where you students can do whatever you like, more or less. After having three pretty well defined things to be done, you can pick anything. And it could well be something, say, about version histories, for instance. Just saying. Okay. Any more questions? We're going to send this out. We're going to send out this timeline again. We're going to send out the timeline later today in the news. Johannes, we're going to do that, right?
Yes, I'm going to do that, right.
We're going to do that, and I have about 1 hour left before the CISPA Christmas party. And I'm going, and then within 1 hour, I should be able to prepare the lectures such that you can watch things again and again as often as you like. Okay. Thank you very much for attending. Have a great end of year 2020, despite all the circumstances. I'm wishing you the best possible Christmas and the best possible New Year you can have. And for 2021, stay safe, stay healthy, and wishing for spring and a vaccine. Thank you very much, and have a great evening. Bye-bye.